Hello, class. In this video, we'll cover the solutions for Lab 53-54. The first problem, we're asked to simplify the expression by reducing to lowest terms. So when you have these rational expressions, you want to factor the numerator, then factor the denominator, and then cancel where you can, right? Cancel common factors. So to factor the numerator, I think we covered this in section maybe 4.6 or so, or 4.5. You want to ask yourself, what two numbers when multiplied result in this last term, but when added result in the middle term? So the last term is -5. So -5 times 1 is -5. -5 plus 1 is -4. So I know that this is correct, right? If I were to FOIL this numerator, I'd end up with this x squared minus 4x minus 5. For the denominator, you're going to ask yourself, what two numbers, when multiplied, result in the last term? -10. But when added, result in the middle term. So -5 times 2 is the last term, -10. -5 plus 2 is the middle term, -3. And then, so once we've come up with the factors for the numerator not on the denominator, we can cancel, right? So x minus 5 on the top, x minus 5 on the bottom, we're left with just x plus 1 over x plus 2, okay? And the method that we chose to factor, this only works when we have a trinomial, right? Notice we have three terms, and the coefficient of the squared term is a +1, right? It wouldn't work here because we do not have three terms. However, for number 2, we can factor out a 12, right? 12 is the biggest number that goes into each of the 36 and 12 evenly, so I factor out a 12. And then I have to divide each term by what I factored. So 36x divided by 12 is 3x. 12 divided by 12 is 1. On the bottom, I factor out an 8. If you divide each term by 8, well, 8x divided by 8 is x, and 8 divided by 8 is 1. Okay, and then we can reduce the 12 and the 8. Okay, and this is our final answer. When I look at problems 3 through 10, okay, so now we're asked to perform the operation. So really, for problem 3, we're going to do what we did in number 2. First factor the numerator and the denominator, and then multiply straight across. All right, so when I look at my numerator, I have 5k minus 35. If we factor out a 5, we're left with k minus 7. And that's really all we can do. Now, in these solutions, we actually wrote 16 as 4 times 4. You don't have to do that, but it helps you see that when we write 20 as 4 times 5, we can cross out the 4s, we can cross out one of the k's, we can cross out the k minus 7, and what you're left with is 5 times k, which is 25k, and 4 on the denominator. Now, if you didn't like how I wrote this 4 times 4, you can leave it as 16. And you can actually just do 5 times 20, which is 100. So you'd have 100k squared over 16k. And when you reduce that, you end up with 25k over 4. Okay? If you look at number 4, okay, another multiplication problem. I factor out a 2. I can't really do anything to the denominator. And the right side, well, that becomes the what two numbers, right? It's a trinomial. So what two numbers when multiplied result in the last term, which is -4, but when added result in -3. So -4 times 1 is -4. -4 plus 1 is -3. All right, so I know that works. On the denominator, I factor out a 2, and I'm left with 2x plus 1. And then I cancel. Okay, I have an x plus 1 and an x plus 1, cross those out. I have a 2 and a 2, I cross those out, and I'm left with this x plus 2 times x minus 4 all over 2x minus 1. I'm sorry, 2x plus 1. And the next one we do division. Now listen, if you can do multiplication, you'll have no problem with division, right? Division, we handle it just like multiplication by taking the reciprocal of the second term. Okay, so instead of 3b cubed over 5b plus 10, we change the division sign to a multiplication sign by taking the reciprocal, right? We flip it. Put the denominator on the top, the numerator on the bottom, and then factor where you can, right? We factor out a 5, and then cross-cancel where you can. Right? And again, we broke this down, the b cubed as b times b times b, and then we crossed out one of the b's. But you could also think of this as b over b cubed, which would be b squared. Okay? And if you wanted, you could multiply 6 times 5 to get 30, and 35 divided by 3 is going to give me my 10. Okay? If you look at number 6, same thing, right? We factor. This is the difference of two squares, right? X squared minus 4 becomes x minus 2x plus 2. Excuse me. The bottom part, or the denominator, what two numbers when multiplied result in negative 2? Well, that's 2 times negative 1. But when added, result in positive 1, right? This is 1k. Take the reciprocal of the second term, right? We flip it, put the x minus 2 on the bottom, factor out an x on the numerator, and then cross out where we can. Okay? For 7, 8, it's addition and subtraction. So listen, if we have the same denominator, we just do the operation across the numerator. So my denominator is 6x for all three terms, so I write 6x. And then I just simply do 1 plus 2 plus 4, which is 7. So 7 over 6x is my answer. For number 8, all right, we have the same denominator, so I'll write y minus 1. Now here's the tricky part. This negative gets distributed to the y and the negative 5. So sometimes it helps to write 3 minus, in parentheses, y plus 5. So you'll know, oh yeah, we distribute the negative to get 3 minus y minus 5. 3 minus 5 is minus 2, and we have a negative y. That's our final answer. And then the last part for 9 and 10, same denominator. So I have x plus 1, and then I'll do 1 plus 3x minus 5. Simplify the negative 5 and the 1, or combine like terms, and that's our final answer. With the x squared minus 9, that's my common denominator. So I'm going to actually do 3 minus x minus a minus 2, right? Minus a minus 2 is positive 2. So this becomes 3 plus 2 is 5 minus the x. And you can leave it as x squared minus 9 or x minus 3x plus 3. Whatever you want to do is fine. Okay? And then the last is just some, I guess, they want you to identify the type of function. So I'll just leave this here for you to read on your own. Thank you for watching. Have a nice day.